Okay, so this is section 7.5. It is on rational exponents. So rational numbers are just fractions. So you're really talking about where you have a base and then you have it to some fractional power. What the top part of the fraction, so this numerator, is basically an exponent. And this this denominator of the fraction, that is your root. So when we talk about roots, you've heard of square roots. So when you have something like this, and we say the square root of 36, we don't draw it, but really there's this little invisible 2 outside of a square root. And what that 2 means is there's 2 numbers that when you multiply them together, you're going to get 36. So this square root is really telling you there's some number, x, that when I take x times itself, I'll get 36. So the square root of 36, as you know, is 6. Or negative 6, because 6 times 6, 2 of them, so there's 2 of them, give me 36. Or you could say negative 6, because negative 6 times negative 6 is also 36. Now, roots don't have to be square roots. You could have a cube root. When there's a little 3 out there, that's a cube root. And if there was a 4 here, you would just call it 4th root. The one that I'm doing right here is a 5th root. And what that means is there's some number that when I multiply it by itself 5 times, I'll get what's inside here. So if it was a 4th root, that would mean some number multiplied by itself 4 times gives me what's in here. So with this particular problem, if I was going to rewrite this, this is basically saying there's 32, this 5, it's the 5th root. And the exponent part, you can put the exponent inside here. So you could say, whoops, it's a 4. So you could say 32 to the 4th power, get that answer, and then take the 5th root. What is usually easier is to take the 5th root of 32 and then take that answer to the 4th power. So if I'm taking the 5th root, so I'm just going to look first at 5th root. What that means is there's some number that when I multiply it by itself 5 times, it will give me 32. So something times something times something times something times something is going to give me 32. I would start small in guessing. So 2 times 2 would be 4, times 2 again would be 8, times 2 again would be 16, times 2 again is 32. So the answer to this is 2. Once you know the cube root or the 5th root, sorry, 5th root. Once you know the 5th root of 32 is 2, then you're going to take it to that exponent. So once you know that this is 2, then you would raise it to the 4th power. So 2 times 2 times 2 times 2, 2, 4, 8, 16. So the answer to 32 to the 4/5 power is 16. And I know that was kind of roundabout, but basically you take the 5th root first, and then you take it to the exponent. Here's another example of that. So you have this 2 is your exponent. This 3 is your root. So the first thing I'm going to do is I'm going to try and figure out what's the cube root of 27. So some number times itself 3 times gives me 27. And so if I did 2 times 2 times 2, that would be 8. 3 times 3 was 9 times 3. Okay, so this number is 3. So the cube root of 27 is 3. Then I'm going to do the power part. So I'm going to square it. So 3 squared is 9. And that's my final answer to this. So this one, the answer was 16. This one, the answer was 9. The other thing they talk about in that section 7.5 is just radicals or roots in general. So they have problems where they use variables. So x to the 8th, y to the 4th, and they want you to simplify it. Well, keep in mind if there's nothing out here, there's actually an invisible 2. And when you have variables, you can essentially just divide by whatever this number is. So this would end up being x to the 4th, y squared. And the reason is, whatever this root is, it's really asking you how many pairs are in here. How many groups of 2? And with x to the 8, you have 4 groups of 2. With y to the 4th, you have 2 groups of 2. Here's another example. If I have the square root of a to the 8, b to the 10, c to the 4. When there's nothing out here, it's a square root. So it's asking how many pairs do I have? So with a to the 8, I have 4 pairs, so a to the 4th. I have b to the 10th, I have 5 pairs. C to the 4th, I have 2 pairs. So again, it's really, you're just dividing by whatever that base is. So this is my answer. This square root sign goes away. When the square root sign doesn't go away, say we had square root, and we're going to say a to the 8, b to the 5, c to the 4th. Okay, so there's nothing there, so it's a square root again. I have a to the 8, that means there's 4 pairs. B to the 5, 5 doesn't evenly divide by 2. But in b times b times b times b times b, you can see where there's actually 2 pairs and 1 b that's left over. So you would say b squared, but you would still need to have this radical sign with 1 b that's left in it by itself. And then c to the 4th, that's 2 of them. That goes evenly. So if there's an odd number and you're dealing with like a square root, there's usually something left in the radical. When it's not a square root, say it's a cube root problem, it's a cube root, so let's say it's x to the 6, y to the 9. When it's a cube root, again, you're just dividing by whatever the root is. So this time it's asking how many groups of 3 do you have? So in x to the 6, I would have 2 groups of 3. In y to the 9th, I would have 3 groups of 3. If you end up with something that doesn't evenly divide by 3, say you have a to the 4, b to the 6, c to the 12. Well, a to the 4 is a times a times a times a. So you have one group of 3, but you would have 1a left in. So you're going to have a, but inside this cube root, you would still have 1a. This b to the 6, well, in b to the 6, you have 2 groups of 3 perfectly. So you'd have that. And in c to the 12th, you have 4 groups. And it's getting a little cramped. So you would have 4 groups would be out here. So that's what your answer would look like. Anything that's left over would have to stay inside the radical. I'm not even sure if your teacher is giving you remainders yet, so you can probably just worry about thinking that whatever is outside here is what you're dividing by. So if you had something like, let's say, this is 3p, 3q, 12, that divides evenly to just give you p, that divides evenly to just give you 4. For right now, you can probably just think of it as standard division, but eventually you will get things where there's stuff left over. So that is pretty much it for section 7.5.